My name is Tomoya Hayashi, assistant professor in INSAT. So from now, I'd like to ask some questions to James Desant.
My particular research interests are actually quite diverse. We've been developing approaches to look at how humans defend themselves against infections, and especially infections that are encountered in the respiratory tract. So when we're breathing, of course, we are encountering potential pathogens, and those can cause disease. This is best exemplified, I guess, most recently by the pandemic and the SARS-CoV-2 infection that everyone has been dealing with for the past years. But our knowledge about how that defense mechanism works is still relatively rudimentary. So we're trying to develop techniques to understand that within individuals in order to help us learn ways to protect ourselves. And this has as well implications for developing vaccines, and especially mucosal vaccines. But beyond that interest in mucosal immunity in humans, we also have a long-standing interest in lymphocyte development, and especially in the diversification of different types of cells that are involved in immune defense. And also we have work using animals as models for human disease, and in particular what we call humanized mice, where the human immune system can develop in animals and can give us insights about the way we as humans can defend ourselves against pathogens, and we can use those mice to study infections that affect humans. I initially wanted to be a doctor. So I wanted to work with patients and take my life calling as service to treating individuals who are suffering from disease. So along the way to getting that training, I entered into a program which actually combined studies in science with studies in medicine. And I realized as I was doing the research part that I enjoyed research quite a lot. And that research provided me with opportunities that were different from the type of work that you can do as a physician, as a doctor. And in particular, one of the opportunities that it provides you is a sense of real freedom. You have a lot of opportunities as a scientist to decide what you want to do, so you can follow your passions. And that, in the end, is something that's very attractive. And in a way, it's addictive. So once you start to have this opportunity to decide what you want to do in life, and you can do what you like, it's hard to change to do something else. So I was doing science and enjoying it, and realized that, in fact, I think I wanted to continue doing science. So I had to make a choice between science and medicine, and I ended up making the choice to become a full-time researcher. So that was that first fork in the road between medicine and research. The other aspect about that was during my research years, I was exposed to people from all over the world. So I had a taste of international collaboration and also the opportunity to visit other parts of the world, meet other people, and learn about other cultures and traditions and ways of thinking and ways of working. And that, in fact, was a real driving force for my wanting to stay in research, because I learned so much by having these interactions with other scientists around the world. And that, I think, is such a critical aspect of the way that we should be doing science. It has to be a collaborative effort, and it has to be a way in which we can confront our ideas with individuals that are in other cultures, in other situations, and try to learn from each other. And I think they continue to guide the way I think about my own research, because the more I interact with people in different parts of the world, the more I learn about new things and new ideas, and then that can lead to new collaborations and new projects.
Yeah, I think so.
You agree? There have been so many wonderful moments in science that I've been lucky to experience. And again, it's thanks to the interactions that you're able to have with your collaborators, and your collaborators become your friend, and in some ways they become your family. And you continue to see them, and you continue to interact with them, and this becomes something that is very personal, and it's very strong. I was first introduced to a Japanese scientist, Hiroshi Kyono, in the early years in 2000, and we discussed about our research interests. And of course, he was studying mucosal immunology for many years. I was not really involved at all in that particular aspect of immunology. We were doing more developmental immunology. And he convinced me that we should start to think more about mucosal immunology. And he introduced me to one of his PhD students who was finishing up her work, Naoko Sato. And Naoko expressed the desire to come to Paris and to start to work at the Institut Pasteur in our laboratory. Now, we were not doing mucosal immunology, but she wanted to continue in that particular area. So we put together a project to start to look at a type of cell that we had been studying, which were natural killer cells in the gut, in the mucosal sites. And actually, there was almost nothing known about this, so this was completely open area. So it was very exciting to start to study this particular area. And very quickly, she was making a very interesting discovery of some new cell type that was appearing in the intestine that had properties that looked like NK cells, but weren't really exactly NK cells. And as this was studied more and more, we realized that this was a novel cell type that had not been described before, that had an important role in defense at mucosal sites. We were fortunate enough to publish about a year later in Immunity, and this turned out to be the description of a subset of what are now called innate lymphoid cells. And these were the gut ILC3, the group 3 innate lymphoid cells that are important in promoting defense at our barriers. So this was really a seminal observation, and it was the follow-up of a starting point, which was simply a discussion between two scientists who had never really worked together before, but were able to find a common ground and find a way to put their forces together and make a discovery because of their mutual interests in two fields. So this goes to show you how if you can bring people together that are passionate and talented and know what they're doing in terms of their expertise, you can really make remarkable discoveries by bringing together fields which are not normally being brought together. So this type of work was also the fruit of a interaction internationally between scientists in Japan and scientists in France. And following from that work, we continued to interact with Professor Kyono and to study the mechanisms of mucosal immunology and develop that in Paris. And that led to the creation of a joint research unit between the IMSUT in the University of Tokyo and the Institut Pasteur. So just a first meeting, which was more very kind way to introduce and to understand what you were doing individually, led to a very strong relationship between two institutes that still persists today. And is followed through with the interactions now that we're having with Professor Ken Ishii, International Vaccine Design Center at IMSUT. And this is, again, a testimony to the way that you can establish durable relationships, even if you're with scientists that are in the other side of the planet, and generate then the kind of relationships that can lead to discovery and help bring new avenues to treating disease and to promote human health.
Yeah, wonderful products.
Yes, the Utopia program, I'm delighted to be a partner in this program. We were interested to learn as well from the experience that's happening now in Japan in terms of the structuring for preparedness for the next pandemic. And I think that is important that we communicate effectively around the globe and share information and try to learn from each other and to build a strategy for preparedness that is going to be one that can be applied around the globe. So we really need international collaboration, international communication. We need partnerships that are strong. And it's easy to say that we need to do that, but then you have to have action. And Utopia is action. Government here in Japan has put together support through the program that really is impressive and takes the whole continuum from basic science into the clinical research that attacks this problem about how we have to set up to be prepared for the next pandemic. I think this is another step in the strengthening of the relationship between our institutes as well as between France and Japan in terms of international collaboration in research. And I'm excited to see how we're going to be able to learn from each other and develop new strategies that are going to be hopefully beneficial for everyone on the planet. So in Utopia, we're developing a integrated approach to understand the defense system in humans, and especially the defense system in the upper airway. With every breath, we're being exposed to potential pathogens. So this is a very important barrier for restricting potential pathogens like viruses and certain types of bacteria and as well as fungal pathogens. So if we can understand what are the determinants that allow for people to be able to resist those pathogens, we can then develop ways in which we can reinforce that defense. And that can help us to eliminate the infection and also to reduce the problems associated when people are infected and exposed to different types of pathogens, including viruses. So our approach is looking at various aspects of this immune defense in normal people and as well as in immunodeficient people. And that will lead us to an understanding about how that defense system works. Now in Utopia, there's also in Professor Ishii's laboratory approaches as well that are interested in trying to understand this barrier and how that can basically be understood in terms of the different components that are important in defense. So approaches have been set up in the laboratory. You know them very well. And we're sharing that information, and we're trying to then compare the approaches and learn from each other. And hopefully that will accelerate our discovery about ways in which we can then use this information and apply it in human health. So this program, I think, is extremely ambitious, and I'm excited to be part of it. And I also hope to learn a lot from the other members. I think that the young scientists should have a following of their passion. So it's important to understand that science is hard, but science is also wonderful. And once you are finding the interest of being able to have discovery of something new, it's kind of like a drug. It's difficult to not want to keep doing that. So science is an extremely rewarding experience in many ways. It's a personal reward. You have freedom. You have a real sense of achievement. It's extremely creative. It's puzzle solving. So it's an extremely pleasurable experience to be a scientist. You're your own boss. So you make decisions, so you're empowered. But it's also an extremely exciting and wonderful opportunity to be able to interact with people around the world. It's an international endeavor, and that's one of the things that also is very attractive in science. It's not just personal, but it's interpersonal. You have an opportunity to meet people from all over the world. You get to learn things every time you do that, and it's an extremely enriching experience. So I would say if you have a choice in life and you don't want to be bored and you want to constantly be stimulated, choose science.